Standing tall like a needle piercing the sky, Tokyo SkyTree rises 634 meters above the sprawling cityscape of Japan's capital, a futuristic marvel that has become a symbol of resilience, technological genius, and cultural pride. But what truly sets this towering structure apart isn't just its record-breaking height or its sci-fi aesthetic, it's the way it stands defiant against one of nature's most relentless threats, earthquakes. In a land constantly grumbling with tectonic unrest, where the earth moves as often as the clouds shift, how does such an immense and slender tower resist collapse? To understand this, we must first look at the land it stands on. Japan is one of the most seismically active countries on the planet, sitting atop the intersection of 4 major tectonic plates. The country experiences thousands of earthquakes each year, many of them imperceptible, but some powerful enough to level cities and claim lives. The Great Kanto earthquake of 1923 and the catastrophic 2011 Tohoku earthquake are stark reminders of the ever-present danger that looms beneath Japan's surface. So, when the idea of constructing the tallest structure in Japan was born in the early 2000s, earthquake resistance wasn't just a consideration, it was the foundation of the entire design philosophy. Tokyo SkyTree wasn't designed merely to impress. It was designed to endure. Engineers and architects approached its construction with a mixture of reverence for traditional Japanese building methods and cutting-edge seismic technology. They took inspiration from an unlikely but time-tested source, ancient Japanese pagodas. These centuries-old wooden structures have stood tall through countless earthquakes, not because of their brute strength, but because of their unique ability to absorb and dissipate seismic energy. The key element? A central wooden column known as the Shinbashira. In traditional pagodas, this central pillar isn't rigidly attached to the rest of the structure. Instead, it sways independently, acting like a pendulum that absorbs the shockwaves and stabilizes the structure during seismic events. Engineers saw an opportunity to modernize this concept, and thus, the Tokyo SkyTree's own version of the Shinbashira was born, not wood, but a massive reinforced concrete cylinder running through the center of the tower. This modern Shinbashira, extending up to 375 meters in height, is supported separately from the surrounding steel frame, and the gap between the core and the frame allows it to move independently during an earthquake. But this central column is only part of the story. Tokyo SkyTree is also equipped with a sophisticated system of oil dampers that act like shock absorbers, strategically placed between the central core and the outer structure. These dampers help convert the kinetic energy from an earthquake into heat, effectively softening the blow. When seismic activity causes the building to sway, the dampers engage, reducing the relative movement between the core and the steel frame and thus minimizing the forces transmitted throughout the structure. In fact, the combination of the central column and the dampers is so effective that the system is said to reduce seismic impact by up to 50%. This seismic isolation is crucial for a structure of this height, where the top of the tower is especially vulnerable to swaying and resonance. The tower is designed not to resist motion but to move with it, a fundamental principle of earthquake engineering in Japan. Beneath the surface, Tokyo SkyTree's resilience continues. The tower is anchored into the ground using deep foundation piles that penetrate through layers of soft soil and reach bedrock, ensuring that the entire structure remains stable even when the ground itself is shaking. Engineers also employed a tripod-based design, 3 massive legs that spread the load of the tower over a wider area, reducing stress on any single point and improving overall stability. This base design not only contributes to the tower's structural integrity but also gives it a graceful, organic appearance that blends strength with aesthetic elegance. The transition from the wide base to the narrow top also plays a critical role in its earthquake resistance. This tapering profile helps reduce wind and seismic loads at higher elevations, preventing excessive swaying and making the tower more comfortable and safe for visitors. Inside the SkyTree, technology plays a vigilant role. A network of sensors continuously monitors the structural integrity of the tower, detecting even the slightest movements or changes in load. These sensors feed data into a centralized control system that can make real-time adjustments or trigger safety protocols in the event of an earthquake. Emergency elevators, backup power systems, and reinforced evacuation routes ensure that the tower can function as a safe haven even during disasters. Broadcast equipment, one of the primary purposes of the SkyTree, is protected in seismically isolated enclosures, guaranteeing uninterrupted communication capabilities during emergencies. In essence, Tokyo SkyTree is more than a structure, it is a living, breathing entity that watches, adapts, and responds to the movements of the Earth itself. But the SkyTree's seismic defenses are not just about survival, they are about symbolism. The very name of the tower, 634 meters, is a play on numbers that evokes the historical name of the region, Musashi. This connection to the past is echoed in its form and function, where ancient architectural wisdom meets futuristic ambition. It is a monument to Japan's ability to evolve while honoring tradition, to embrace modernity without forgetting the lessons of the past. Every beam, every bolt, every line of code in its monitoring systems tells the story of a nation that has learned, through hardship and innovation, how to coexist with the uncontrollable forces of nature. As the sun sets and Tokyo SkyTree glows with its nightly illuminations, sometimes in soft indigo, sometimes in festive colors, it stands not just as a beacon of communication or a tourist attraction, but as a silent guardian. It reminds the people of Tokyo that they are watched over by something stronger, something smarter, something built with both heart and science. The next time the earth trembles beneath the city, the SkyTree will sway, absorb, and stand tall once again. And in that graceful sway lies the answer to the question, how does the Tokyo SkyTree survive earthquakes? By dancing with them, not fighting them. By embracing motion, not resisting it. And by standing not alone, but as the culmination of centuries of architectural resilience and modern engineering brilliance. This is how Tokyo SkyTree survives earthquakes and how it inspires the world to build not just taller, but wiser.